around. But actually, maybe that's a good good segue to get started with. So some updates from the project. And how does time even work? Was that last month? I can't remember. Zishan and I
maybe like two, I think 2 months
ago. Yeah, a while ago. Zishan and I went to Boston for COD summits, computer over data summits, presented about IPVM and Homestar respectively. So Homestar being the Rust implementation, and you know, kind of saw everybody else in the space that's doing sort of, you know, related work, et cetera. Had some good conversations. People seemed excited, which is really great. And us having a couple specs has actually been really helpful. So talked to a couple different teams, and they're like, hey, you know, we're trying to approach these kinds of problems, and we're able to say like, hey, you know, here's a spec. I don't know you can invocations, but if you need to do workflow things, which actually a lot of people turns out do, we have a spec for that as well. So you know, it's led to some conversations about even like what is an IPVM, right? Like, is Homestar, you know, do you have to be totally Homestar compatible? How many of these pieces can you take and still be like an IPVM? I think the current answer on that is, as long as you're following the specs, you're going to be at least interoperable to some degree. We'll be able to call into each other's systems. And so I would call that an IPVM, right? So say Bacalhau were to implement the workflow spec, for example, then they are also an IPVM, right? Whether or not they do all of the extra stuff that we do with, you know, virtual resiliency and, you know, all this extra stuff. We also, there'll be a post soon about this, but we got a grant from Archaeological, which is the IPFS implementers fund, basically. So super exciting, really glad to have the support from them. Also means we'll be bringing on 1 or 2 more people to help with the project, which is really great. So if you know anybody with distributed systems background, we're going to put up a job post shortly. Send them our way. Doesn't mean that people can't contribute just in general as well, right? So like, happy to take all contributions, but we're actually going to be able to hire with some of this funding as well, which is really great news. And then last thing from conference stuff, Strange Loop this year, final year of Strange Loop. I'm going to give a talk about IPVM as well. So lots of stuff on the conference front there. Aside from that, the spec work and implementation continues to roll forward. Zishan, do you want to talk a little bit maybe about Homestar, and then we can do sort of like a open up for updates or any questions from other people?
Yeah. So yeah, been hard worked at Homestar, which for people who are not familiar, it's like what I guess we've called the reference implementation of IPVM that we're building here at Fission. That you know, implements a lot of the UCANT invocation spec, but it also has kind of gone further with our, you know, the specs that have been kind of in progress around workflows, and you know, workflow engines and workflow systems. And so at both that IPFS thing and that compute over data, and I recommend actually, you know, from my talk's perspective, the compute over data one that I linked. We do a demo in there showcasing some WASM execution with incremental you know, reuse of receipts that are all about the spec, and we can talk more about that. But it also goes through a lot of the stuff we've been thinking about in terms of workflow systems that we've been looking at, thoughts around failure, virtual resiliency, which is also comes up a lot in Brooks' talk. And so, yeah, Homestar, where it is today, is essentially getting, you know, where that demo was to kind of showcase what we, you know, what we could do with WASM and executions, and where the demo, where the code is today, is essentially there to actually start running configuration of workflows. Eventually we want to do a lot more tooling where people don't have to write configuration, but if you can think of something like GitHub Actions, is kind of what we're doing as a first pass of this, though probably JSON and YAML, but nonetheless, the ability to write out some JSON and then have that actually execute a workflow. So that's a lot of the internal code has really been around getting code in place where, being an open world system, we can't just rely on using, SQS and AWS or things like Kafka. So we built our own runtime, which Homestar is composed of. And for people who maybe have looked at the code base yet, and maybe at the next community call or one we could do later, I can go through all the code in different pieces. We've broken up everything into essentially a core, which is implementing UCAN invocation, and now starting to implement what's in the kind of draftiness of what an IPVM workflow is, and that's kind of in the general core that people can build off. We have a Homestar WASM crate, which is more about working with the WASM time runtime, WIT and IPLD, which is about 70-ish% done in terms of the interpreter that we have there that goes between WIT and IPLD. And also, is able to execute WASM right now only as a backend runtime in Rust with the WASM runtime, and executing things like being able to execute WASM functions over the same store without having to instantiate extra modules and stuff like that. It's all kind of baked in already and pretty well tested and integrated. And then the runtime is essentially, the runtime we're building out, which right now is just like a binary that runs up, just can essentially run up a single workflow, but we'll be able to run essentially in server or daemon mode to take a bunch of workflows and run them concurrently, and then eventually have more more things as well. We build it out. But where the runtime is right now, essentially, it's the ability to do like schedulers. So we schedule how we do how we execute a workflow of various WASM functions today, and built into it is WASM being first class. One thing we talk about both of our talks, and we also have a lot of stuff issues that we've been putting out on the Homestar repo, but we haven't really designed yet. Is the concept of a plugin system. We would like people not having to run their own, implement their own runtime. It's a lot of work. We've been doing a lot of work. We don't necessarily want people to always have to do their own runtime for this stuff, and so pieces that we've been talking about that will probably become more specs as we build this kind of open world distributed compute engine, are things like being able to run Homestar in different modes. So it can run as a compute mode, but it can also probably run as an agent where it can communicate things like through lib to lib P2P. But you have your own compute. We've talked, for example, like in the Bacalhau case or Expanso case, where Docker runs, they would run Docker things, but our agent can be there to make sure that things like receipts and all that are translated and then work across other versions of the runtime. The things that interoperate with IPVM, and also things like as we start moving into things which is coming up pretty soon, bootstrapping nodes, coordinating. So there's a concept that we've talked about. Obviously, it's pretty normal in distributed systems work, is the difference between like what's actually compute and executing versus what's coordinating, and who should coordinate, determining who should actually execute something, which is a big part of again both of our talks and where we're going with the runtime. So that's kind of where the runtime is today. Right now, simple workflow execution, a lot of WASM is first class, with all the stuff we've been doing with the WebAssembly interface type system. And then a lot of cleanup around, errors and again, the separation of all the crates between core WASM stuff and other stuff.
Yeah. And then I guess the final update with work that's happening at Fission, at least. So we started, or for a while now, we've been rewriting all of our stack in Rust, which has given us the opportunity to rethink how some stuff works, and talking to other teams about, federation and, not having to have every team boil the entire ocean. And it turns out that UCAN invocations and having the delegatable bit on there is actually really useful for this. And so we're finding all kinds of uses for essentially, what the ICAOS has been talking about for a while, of this using UCAN as an RPC interface for bridging between systems, which has kind of always been the hypothesis, but actually seems to be bearing out now. So it's the same building blocks, even down to things like workflows. But instead of in an IPVM context, it's really focused around services. And at least in theory, when this is all built out, you'd then be able to call anybody who's implemented these interfaces will also be able to be used as effects from an IPVM invocation, right? So all of this stuff should tie together as just sort of like one interface for all of these use cases. It's actually turning out to be actually pretty great so far. I'm sure that there will be bumps along the way, but so far seems to be going pretty well.
I
Anyway.
also wanted to add one thing for too, that we already started looking at how the implementation of I guess shim runtime for the browser will go, where we can be able to run the same sets of WASM compute, for example, in the browser, and also thinking about what are the offline ways we make that work and stuff like that using IndexedDB. Already having some of those conversations. All the kind of networking libp2p component will always happen over relay and through backend servers that have to be like online. But if you have, the idea of storing, we already store caches today in the runtime. You could have caches in the browser, be able to run things offline, and then execute using the WASM time tooling with the JavaScript. It's called JCO, which is their host runtime for JavaScript to run the same WASM module. So that's also in our next months of work.
So those are the fission updates, at least. Wanted to open it up to everyone else if there's anything, because it's been a couple months since we've run one of these. If anybody else has updates from their side for UCAN notifications, IPVM workflows, and any of this stuff, or other closely related projects.
I can give a little update on what's happening on the Dachau side of things, although I might get some of the timing wrong because it's been a while. We did ship receipts, but not fully spec compliant yet. So basically, we really wanted to ship receipts, but we needed to cut the scope and not ship all of the invocations. And that is basically what we end up doing, which does mean that receipts point not to the what we end up called, I believe, operations, or not operations, I forgot what we call, but commands or something. But they right now still point to our delegation CIDs, but that will change as soon as we implement the rest of the stuff. So we did tag them differently, so it's not to be confused with actual receipts, but hopefully this sets us up to have them soon. And that is also part of the Ucanto stack, which is basically our RPC layers that does client and server part. Other than that, we also started kind of working on what we call Spade proxy. And if you do not know Spade, it's a protocol that is being built by people at PL to do the aggregation deals on Filecoin. So right now, when users upload stuff to the Web3 storage, they come in as smaller pieces usually. So there would be car files, but not really big ones. In order to end up those in Filecoin, we usually create this thing that we call aggregates, which are a bunch of pieces. And pieces here, the Filecoin term, to basically refer piece of data. And you derive its identifier in a slightly different way. It's not a content CID, it's a little more complicated. I'm not gonna go into this here. So out of multiple pieces, then you can create an aggregate, and that's what you usually arrange the deals with. So that piece of logic is not exposed to external parties, I believe, at least for now. So what we end up designing and working towards is what we call spade proxy, which is basically a HTTP endpoint that takes UCAN invocations for the creates offers for those aggregates, and then takes care of dealing with spade itself, and then gives you back to receipts. Effects also end up playing a role there, because the process of creating aggregates is usually put a bunch of pieces and you create an offer. But then there's the whole going to the marketplace, trying to find the deals. Once you'll find storage providers that will then try to get the content from you, which may fail, or maybe some of the compute was not correct. So the way it ended up being designed is you create an offer, which is the invocation, which will get an effect link for the, like, I forgot what we call it, but like finish of the offer, or like arrangement of the offer, which may or may not fail. And that arrangement is this long process of doing all the things that are hidden behind the scenes of how it works. But once it's done, then the receipt is issued, and you should be able to see whether it succeeded or failed. Yeah, maybe that'd be mouthful, but that's kind of exciting that we'll be doing more of the UCAN stuff. And the hope is that either Spade will then take ownership of that and expose it to the rest of the world, so they can have different clients using it, or maybe we'll continue running it. Not sure yet, but that's a state of affairs. I think that's all of the UCAN related stuff that we'll be doing.
Amazing. Could you, if there is a link, could you post a link to that? I hadn't seen that project before.
There is a spec that is still work in progress. Some of the designs we had initially misunderstood how the pieces and aggregates worked in Spade. So some of it is being changed and in flight, but I'll post a link in a sec to the specs that I'm referring to.
Amazing. Updates from anyone else? All right, awesome. In that case, and as always, people feel free to jump in at any time or use the Zoom raise hand question functionality. I thought it might be interesting for us to talk a little bit about how we've been thinking about integrating IPVM with IPFS, because obviously that's still effectful a little bit, and not a little bit, it is effectful. And this has come up a few times recently, like in the past couple days. The design of it has come up internally, but then also it's a point where I've had to explain it a few times to different people, because they're like, oh, but like you have this separation of like pure functions from effects and you're doing network stuff. Isn't that a little bit strange? So figured I can describe that here, and then as if people have questions, we can just talk about it, and then we have it on video, right? So may be helpful. And I think the only time that I've actually talked about this sort of like in front of a more public group was, or spelled it out like in that much detail, was actually the COD Summit video that Zishan posted a couple minutes ago in the chat. But basically, so IPVM, starting the name, needs to work with IPFS. But we want determinism, right? And so great, we have integrity hash that lets us know that we're working with the same bit of data, and that we can, we probably want to be able to stream blocks in, a block at a time, so that we don't pull down, a terabyte of data if we're working with something, from a lower resource machine. So we need to have data streams. Streams can get interrupted. You might only have some of the data, like maybe you only have the root block, but not everything below it, like all of these different cases. And there's no way of proving in advance that you'll actually be able to get all those blocks. But you can get a guarantee from somebody in the system that they will promise, pinky swear to actually serve it to you. So it becomes a question of who's at fault if you can't actually get the data, right? So in the same way that somebody can do computation for you, and then it's done wrong, and you've, do say optimistic verification, and we, it's like, oh, there's a disagreement here, and we're going to slash them. Same thing for somebody who's providing data to such a system. So you basically say, hey, I would like, or we want to keep this abstracted away from the user as much as possible when they're writing a workflow, right? So they'll just have a regular CID. The engine will look at that and say, okay, there's CIDs here, here, and here. I know that this this step expects to have access to that. And in fact, statically, we can, ahead of running anything, say, hey, here's the ones that are actually hard-coded. I'm going to check those in advance before I even do any computation, because there's no point even starting if I can't get the data at all, right? So we essentially insert a step at the beginning that says, hey, who can actually provide these to me? They negotiate. You get back a basically a certificate that says, like, yep, I promise that I will serve this to you for the next however much interval of time. And if they then fail to do that, you can slash them, right? So it's the same thing. You're getting a determinism guarantee about network performance as opposed to computation, right? We called this a content handle. We're actually finding it to be kind of useful in a number of places, because a CID doesn't actually give you anything other than the hash, and I can describe how that hash is put together, but I don't actually know that I can get that data. And so even when we've built stuff in the past with IPFS, or even with, say, different versions of UCAN where we're trying to do caching, and we've since moved away from doing caching purely on IPFS. We actually like to send them around with the request directly, but knowing if something is already cached and local versus I'm going to have to resolve this from somewhere on the network is kind of a different case. At least it's a different code path. And so this lets us encode directly. Hey, I actually know that I can get this one, and or at least I have a higher degree of confidence of that, and that has performance implications. Different levels of different kinds of errors that you expect out of it, different expectations for, okay, I know that it's going to be specifically here. I don't have to try anyone on the network. I can try specifically this one. And it seems like a generally useful pattern, and one that should have little, if any, runtime overhead other than doing that initial negotiation of like, yep, I can actually get this. At the implementation layer, I've always been thinking about this as a new type, as the pattern for it. So you basically are forced to, in your code, do this check first, get the handle as opposed to an ID, and now you can thread that through your code. Seems to be a generally useful pattern. We'll probably write up a spec for it totally separately from everything else. But it's another one of these pieces that seems to be coming out of this general body of work that might be helpful. But that's the explanation of like how we're planning on doing this for certain kinds of network access. Is that generalizable to other things, like saying, there's an email provider over here that can provide things at example.com emails. And I need them to be available for the next 10 minutes. And they promise that they'll stay, that they'll have resource available for me to actually send the email. Like, we could generalize it to that as well. But the main hard use case right now is there's a terabyte of data over there. I want to be able to stream it in a bit at a time. I need to make sure that they're up, and that maybe I need to, replicate that across if it's really if I must have, however many nines of data availability, maybe I need to do multiple of these negotiations in advance before I even start. So that's the basic idea.
Can I ask a question?
Yeah.
So how does this content handle manifest itself? Is it a runtime thing, or is it has some on-wire representation as well?
Yeah.
So
the current thinking is that it should not have a serialized representation, because it is, at this point in time, I know that I can get it from over there. Like, I shouldn't share that around, except as like the proof that I get or the negotiation that I get. Maybe we could make that available to others, but it is a point-to-point guarantee, at least the way that we're thinking about it, because we need to be able to consume it. And because you've agreed to share it with me, doesn't mean that you've agreed to share it with somebody else, because maybe there's a network firewall or all these other possible caveats. Being able to say, actually that's interesting. I hadn't made this connection before. So obviously, Irakli and I had a call with Michael a couple of weeks ago about using some of this stuff to some of the same building blocks to essentially attest to, hey, this block is inside of this other data structure, for example, right? And providing Merkle proofs to things and whatnot. Actually, yeah, that's interesting, because maybe you could actually then say, actually gossip that information around, as opposed to it being a availability guarantee for a particular provider, provider consumer pair. You could say, hey, I saw it over here.
There's a relevant node I think might be worth raising here, related to this aggregate space that I was talking about for making deals in Filecoin, and some of the content claims that you referred to that Michael had been doing. So let me give a little bit more detail that I omitted earlier. So the way the aggregation works is when you make a deal, you basically negotiate by this PCID, which is computed, roughly speaking, like each piece is computed as a different algorithm. You shard the content in a different way, not as a file or any other IPLD structure. And then you basically build a Merkle tree of the content. And that the root of the Merkle tree is basically the piece identifier made into CID. So there's this indirect map, and there's a padding and stuff going on too. So there's this indirect mapping between content and the CID. It's a funny fact, and maybe very unrelated here, but what Iro is doing with BAO is a very similar process, except you don't end up with two different CIDs. It kind of ends up being the same. I lost my train of thought, sorry. Oh, yeah, so the idea is that you create deals out of those. At the time of trying to arrange a deal, you basically talk about the CID and what the size of it is. When the deal is sealed, network will ask you to sign and give basically set of URLs where miners or storage providers can fetch the content from. And that is signed by you. So I think there is this element which is really interesting and somewhat related to what you were saying earlier. So you have some content identifier, and then you basically issue an access to it to get it from specific location. And in this case, those are literally HTTP URLs. What we've been contemplating is, as opposed to just sending a URL, to do a UConn delegation instead to the storage provider who will be taking it for a specific duration of time within which they can get it, and also give access to only them to do it. Obviously, they can share it with others, but that's kind of separate. So there is a little bit of overlap here that I think is interesting. On the related note, we also, doing this work, we realize that computing this piece identifiers on a client had other troubles because a lot of SHA-256ing happening. My hypothesis is that browsers are intentionally throttling it to stop crypto mining from happening, because if we just use ingest implementation or anything, it's magnitudes faster. So we're actually, before it was the idea that on every upload clients will provide that PCID as well, which we're moving it away from, and we'll have two separate calls. And associating car CID with PCID will be a separate UCAN invocation, which will probably also make into the content claim. So we can share it with broader networks that they can do those kind of lookups. Again, this was a mouthful, but I think there are a lot of overlap with this that might be interesting to explore.
Yeah, on the slow SHA-256, we also saw that in WinFS as well. Interesting hypothesis about the crypto mining. Our current working theory was that it waits for the event loop, and so it's actually like really slow to get there. We switched to WebAssembly for doing most crypto, unless we needed the non-extractable keys from the Web Crypto API, yeah. And it sped it up like hugely, like 200 times kind of thing, which is unintuitive, right? You'd expect the one baked into the browser to be hardware accelerated, when possible, or like with a really fancy C implementation or something. But nope, it's really slow. Yeah.
So we've considered the awaits being the cause of issue, but I'm pretty sure it's not, because we had a iteration of it which just used ingest implementation of SHA-256, but still keeps the API async to do those awaits. And honestly, the difference between it being sync and async was negligible, while using a native crypto API versus not. That was huge. While I was still at Mozilla, there was interest, at least, in discussions around stopping crypto mining from being an abuse vector. So that is hence my theory that probably went into effect since, which had been several years now.
Interesting. Yeah, I mean,
makes sense. I think maybe what you're observing with WASM is kind of same thing. It's not been detected as that huge number of SHA-256 has been created.
Yeah. Ben?
Yeah, I just wanted to make a quick comment / question on, when you talked about this data availability problem, have you considered sort of generalizations of that, where the data may be actually something that needs to be computed? So you actually have effectively some sort of promise that I can complete some computation that will then return the data that some other one needs, some other process needs?
Basically, yes. So in IPVM, the base layer, every node must be able to execute pure deterministic WebAssembly, right? With no other, special effects on it. And we're going to add a what we historically called a microkernel architecture, but it's really like a driver for IPFS data. And so the way that these parts connect together is to say, I know I can get the data from over there. It'll come in and I'll do all my transformations in WebAssembly, and then I can pass that out to another step, right? So we have a whole workflow. Basically, we're injecting this step of check that you can get the data and actually stream it in. And we'll give the deterministic WebAssembly, because we have the guarantees of data availability, and then inside determinism, the ability for it to grab data off a stream as if it was fully loaded.
Okay.
And then it can pass that off to the next step. And where that WASM happens is up to the coordinator that Zishan mentioned earlier. So it could actually be on the same node, but you also may have nodes that are just specialized in like data retrieval, and they don't want to run computation.
Okay, so I guess to clarify a little bit, the question is like, you may want to perform some computation, but I may not even want to attempt this computation unless I know that I can get all of its dependencies in some sense. So
Yep.
is this along the right lines of what you're saying?
Yeah, exactly. So you'll say, I want somebody who can give me access to this CID, but then that implies everything below it in that Merkle structure. And so you'll have somebody say like, yep, I have that entire structure. It's a petabyte of data, right? It's like, okay, great. I'm going to stream that from you a block at a time, right? Or get the whole thing, or however I want to fetch that.
Right.
Or
You run Homestar as well. You have WASM. You already have the data.
Yeah.
So how about you run it at your node, right? Instead of doing that stream over. But that's kind of this, to your point, the coordinator can actually determine that. Or it's like, yeah, we have to stream that in, but we can say now we have everything, then we'll run it.
Yeah, but from the point of view of the WASM execution, whether or not it's sitting next to it on the same machine or it's across the network, the actual flow looks basically the same, right? It's mainly a question then of latency, and the coordinator is going to try to limit latency as much as possible. So if you have a node that says, I'm willing to run computation and I have the data, and the data is large enough, we're almost certainly going to push the computation to the data rather than fetch the data and operate on it locally. If you have some, and the cost semantics there, and like the cost dynamics are an area that we still need to figure out fully. It's deciding where to run stuff and the latencies between them. And in an ideal world, you have all of the data sitting right next to the compute, and you have zero latency. It's right next to each other, right? But that won't always be possible. If you need to do a CUDA job, right? You're doing something on a GPU, and the data provider doesn't have a GPU, you're going to pay for that network in between.
Okay,
but then, yeah, in advance, we need to figure out, or at least make good guesses on which of the scenarios makes more sense, basically. And there is some academic research on this already. It exists, but it always falls into some realm of heuristic, right? Because you're looking at the network and all of these things.
Okay, that makes sense.
I think I realized I mentioned it before too, but I think there's this interaction between here's the CID and here's all the places that I can get it from. And it's not always going to be the case that all of the subdoc is in one place, right? So it feels like maybe that needs to be entangled. At least we've been finding more and more using IPFS realm that is true. Like you cannot just say CID and mean all of it. I don't have any specific suggestion here, but perhaps there's like intermediate step where from the CID you resolve the locations, or I don't know, like maybe not location, but some notion of addresses, and then look who can provide those. That is a little more deterministic than saying that whatever the graph is under. It doesn't also resonate more with how Filecoin thinks about things. That's why the PCIDs are very different from regular CIDs, and they don't care about what the bytes are representing.
Yeah, no, totally. And actually, this is a thing that we talked to a lot of other people that are using IPLD about, like outside of PL, that just because you have the root doesn't mean that you have all of the leaves, right? And so sometimes that's what you want. You want to say like, well, this content needs to be forgotten. I don't want to have to go and rewrite the entire structure. Let me just drop that from my storage, right? And nobody else is holding it. Cool, it's gone, right? We've thought a little bit about, when you're computing over some graph of data. Let's say you only need this slice, not the whole thing. You can start to get into cases where it's like, well, I only want to make sure that this part's available, but that is also computation, right? So like, as soon as you start doing graph description, you're now asking them to go and walk certain parts of the structure rather than this general algorithm of like, yeah, no, totally, I've got this thing pinned recursively. And so one approach to that is to say, well, we'll just build that as part of a IPVM workflow that says, check that all the data is there, or like that this subset of the data is there because I can touch all of those nodes. And then on the outside be like, yep, checked it, and then continue on. Or we can make that a first class thing, but you know, now you basically need to charge for like charge for the gas, you charge for all of these other things, right? And the complexity of the different approaches, you know, starts to factor in and wanting to be able to upgrade those. So actually building that as IPVM workflows that are then reusable is actually maybe not a bad approach, has been the thinking. But yeah, just to keep things simple, we've been thinking of it as like, we just want you to guarantee that you can have the entire structure, as opposed to like, well, they have this app and this other one has this app, and I'm going to like merge them together. That would probably be its own workflow, or sub workflow, I guess. Unless there's been some approach that you've found, Irakli, that makes that easier, maybe.
So what I want to say headed, but it could be like we're biased on our team, but the content claim stuff that have been mentioned is kind of how we're thinking about it. There's all like, in reality, indexer nodes on IPFS network is kind of where the most of the information is, and how like not full-fledged IPFS nodes get the information of where to get those from, right? So I think the thinking is that we're gonna just lean into that, have those kind of nodes where all of these associations can live, because in reality, it's not blocked usually, unless you're really talking on your like laptop. So it's usually the block you're asking is within a car, and that car is usually at some location that you can get, and ideally not have to run IPFS node to get it. It's been thinking. So the content claims thing is kind of what we're trying to approach it with. That way you can go from block to more like the, I guess, kind of sector of blocks, and from there where I can get it from, and hopefully get that information from indexer nodes. So you can easily find it. You can still go with BitSwap and try to chase your blocks that way, but hopefully there's this like fast lane. With that said, I think it might be worth considering, like if IPFS does transition to more of that kind of model, would the design you're going for still make sense or not? Because it seems like Lassie was another IPFS node thing that I'm not as familiar, but they also moved away from like BitSwap and blocks and really operates on the cars. Filecoin is also found like block level.
Is there something written on the content claim stuff?
Yes, I can share a link.
So I agree that moving away from blocks is almost certainly what's going to happen, but it's still described in terms of blocks, right? Like IPLD is still represented that way. So whether or not it gets served over BitSwap in particular, or we get a car file that has like some, you know, let's say that it's an in-order traversal of the graph or something, and you're like, well, I'll take page 1, page 2, page 3, you know, as I walk through the structure or something. That's also equally good. It's mainly about, can I get this stuff at all, right?
I think what I'm getting at is the knowledge of the graph is, we're trying to remove it from the system. So a lot of nodes would not know it. Like indexer node might know, and they will index it. My application may know, but all the nodes who store the data or provide the data, they don't need to know. Or even the nodes that are looking for the data, they don't need to look for it. They can just try to basically traverse the graph without having to actually do that. Just find the traversals that somebody did. And thinking is that applications that produce those data are in best position to kind of provide an index with it and share it with the network, so nobody else has to do this kind of exercise. So let me traverse it and find where things are. And ideally even optimize probably location and some other variables that you can tweak to make it more efficient.
Right. But that's all done at right time, right? Like you can't package that up after the fact.
No, so this is kind of so at right time it would be probably you're in the best position to do so. But by separating, that also means that you can hire someone to do that indexing and providing that information. It doesn't necessarily have to be every single node who has the data now need to know. Now you kind of decouple those two pieces. Kind of as I mentioned with the comp, right? Like we wanted to first make clients compute it, found some issues like doing in the browser. Another option was, well, we can compute it as we get the data. But by doing through the content claims, it means, well, anyone can compute it and make a claim about it, and suddenly it's available. It could be us. If users pay for us to do it, they can do it on their own, or it could be an entirely different party doing it.
Like a hypothetical distributed computation network, for example.
Yes.
Okay, interesting. Yeah, but the data underneath is still like IPLD normal linked data. Like if I got all the pieces of IPLD structure off of multiple cars, I still get like some Merkleized data structure, right?
It's more like you can do that, but the idea is that, well, maybe not every node in the system needs to know or do that. Like as a storage provider, like we don't want to care about it. Like, so it could be different codecs. We may not even be able to work the graph, or it might use some hashing algorithm that we cannot work with. So like, there are all those things that kind of end up intertwined if you assume that I can walk the graph, but if we don't, then I hopefully there could be more layers.
But the application will be able to, like, once they've resolved the data and they have it locally, it gets resolved into flat files or into a graph?
It's HTTP range requests is kind of what we're hoping you can get. So you know a CID, you do the graph query with the indexer nodes, hopefully. And you get all the pieces of information that you can do multiple range requests to get all the block sets that together constitute your graph. Now that CID may not even represent the DAG, right? It may be, well, I'm doing this query on a DAG and I call that this, and an index is provided for it. So it could be at the query level, it doesn't have to be at the DAG. So we're kind of trying to abstract the DAGiness of it. And nobody except the consumer needs to really know how to piece those things together, right?
Interesting. So basically I could pull down an index, like let's say that I had some sort of graph data, right? I could pull down an index and then know I need to get this range here, that range there. And like I could just basically schedule in advance. Here's the bits that I think I'll need. And then
exactly.
Okay. And then in this version for IPVM that I was describing, you'd basically make deals, like availability deals with whoever has those chunks and be like, hey, you're going to be online for the next 10 minutes. Great, cool. And then you can grab those as needed or
for rich. You're talking about retrieval from Filecoin or writing to Filecoin?
Retrieving data from an arbitrary service provider over HTTP. The range request.
I mean, they don't necessarily do that stuff. They have their own notion of a piece. So you can try to make an offer to the storage providers, which is kind of Filecoin nodes, saying, I want to store this piece of data, you know the size, you know the its identifier. Once the market finds the nodes who are willing to do that for the specific costs, then they reach back to you and saying, hey, I want to do this, and basically set of URLs that I can fetch it from within a certain amount of time. And then they can use that to fetch it. So they don't really do range queries because they assume that it will be one HTTP URL, but in theory it could be. What we're designing is trying to be more efficient to do the range queries. Mostly because, what's called Saturn and other development that is happening also within IPFS network are trying to move the IPFS node into service worker that doesn't need to necessarily do all of the P2P transporting, right? And that is where it would be very helpful, because then this node can be very simple. They can just query the index to find out what HTTP queries they need to do to get all the blocks they need for the specific content, and then like build it up locally. Hope that makes sense or answers the question.
Yeah. Awesome. Just a quick time check. We have 7 minutes. So if anybody has a burning question, this would be or want to share something, this would be a great time. Okay, cool. So we're back on the regular schedule. We'll be getting these back onto the monthly now that the massive amount of travel and events and conferences seem to be mainly wrapped up, at least for the next little bits. We've not done a great job of keeping the agendas posts on the IPVM spec / discussions going, but we're going to start doing those again. So if you have anything that you want to talk about, feel free to throw it on there in advance. There's a bunch of spec work that's still going forward over the next little bit here. I've kind of wandered back over into database land for a little bit for a separate vision project, but I'll be back mainly to work on the task type specs relatively soon, and also need to upgrade the workflow spec to use the latest version of UCAN. So for those of you that follow UCAN, the capability certificate spec that all this stuff is built on top of, we did a major release of the spec a month ago, maybe a little more than a month ago, 0.10. Don't tell anybody, but that's essentially the 1.0 RC, assuming that we don't find anything wrong with it after we finish the implementation, which then makes it much easier to upgrade the, actually, I think the invocation spec already has a bunch of that stuff in there, but then the workflow spec as well, to match all the latest from the other specs. So they're being built up in layers. Task type spec, we've needed for a while. Right now we're kind of doing it by convention, but then we'll have something a little bit more put together as well. And then also specs for things like this content handle idea, though it sounds like there's a bunch of work happening over inside Protocol Labs that maybe we need to take a look at first, which would be possibly helpful. So yeah, the specs will continue. The code on Homestar will continue. Hopefully in the next little bit here, we'll also have some sort of like a movement towards a standard library on WASM types. Today, I believe, correct me if I'm wrong, Zishan, we only do WASM in Homestar, but we hope to have some first party effects like HTTP, DNS resolution, things like that.
Yeah, everything is deterministic right now, but yeah, baked in effects, plus some, as we talked about, some baked in helpful kind of WASM modules to use and prototype as well, as we talked about the other day.
Yeah. Awesome. Yeah. Anything else, Ishan, or should we give people their 2.5 minutes back before the end here?
And nothing else for me today.
All right, awesome. Fantastic. Well, thanks everyone for showing up, and we'll see you all at latest in the month. Otherwise, please drop us a line in Discord.